Just want to do one more example to help you finish assignment 3.3. Problem says find the tangents to the curve y equal 2x cubed minus x at the points where the slope is 5. So you get this curve, and you want to figure out the equations of the tangent lines, but they don't give you an x coordinate, but they tell you that the slope is 5. So to find the slope, we do the derivative. So dy over dx, or you can call it y prime if you want, equals, so do the derivative here would be 6x squared minus 1. Yeah. Remember, this represents the slope at one point. So what number can I plug in place of dy over dx? 5, because they're giving you the slope at some particular point. So 5 equals 6x squared minus 1. So I just add 1 to both sides. Get 6 equals 6x squared. Divide by 6 on both sides. 1 equals x squared. Be careful here. X is going to equal two possible numbers. What are they? Positive and negative 1, right? Okay. Now, so what that's telling me is there's two places where the slope is 5, at positive 1 and at negative 1. So what I want to do is to find the 2 points, I want to plug 1 into here to get my y coordinate. So when x is 1, when x is 1, y would be 2 times 1 cubed minus 1. So that would also come out to 1. When x is negative 1, you take 2 times negative 1 cubed minus negative 1. So let's just, so that's going to give you negative 2 minus negative 1, which would be plus 1. So that comes out to negative 1. So one important thing to learn from that or to remember is that if you know your x coordinate, you want to find your y coordinate, just plug your x coordinate into your original equation. Okay, don't make it too hard, it's not that tough. Now we're supposed to find the equations of the tangents. So for that, just use point slope form. Y minus y sub 1 equals m times x minus x sub 1. So in this case, it'd be y minus 1 equals, what would I put in for slope again? 5 times x minus 1. Distribute the 5 through. On the right side, you have 5x minus 5. Add 1 to both sides. You get y equals 5x minus 4. So that would be your first tangent line equation. Any questions about that? Okay, the next one. Exact same thing, except now you're going to plug in negative 1 for y and negative 1 for x. So it'd be y minus negative 1, which would be y plus 1, equals your slope of 5 again, times x minus negative 1, which would be plus 1. Distribute the 5 through again. Subtract 1 off both sides. Y equals 5x plus 4. Let's check our work with the graphing calculator now. Any questions about that?
Is it like every time for like the opposites, like the same?
Like, will always come out to like 1 and negative 1?
Like, no, will the y coordinate always be like opposites? Like opposite signs?
No, not necessarily. Like, were you saying like this is 1, this is negative 1? No.
Or like 5x minus 1, 5x plus 1?
No, not necessarily. That's a good question, but not necessarily. Okay, so let's go ahead and, the reason that that's happening the way it is because notice that these exponents are odd. That's to the third and that's to the first power. This is an odd function. It's going to be symmetric with the origin. So it's kind of a special function because it's odd, and that's the reason we're getting those types of answers. But, so I'm going to go to y equals. I'm going to type in my original equation, 2x cubed minus x. Then I'm going to hit zoom 6. Okay, I probably don't need to see that. Let's change the window a little bit. Let's change the window. Let's change the x min to negative 2, x max to positive 2. Because I know I'm really interested in these 2 points, 1, 1 and negative 1, 1, negative 1. So I can, as long as I'm including 1 and negative 1 in my domain, I can go from negative 2 to 2 here. And hit graph. Okay. Now let's try graphing those two lines. Let's go to y equals. Y2 is 5x minus 4. Let's hit graph and see if that looks right. So let's hit trace 1, enter. Yeah, looks like that's the point of tangency right there. All right. Now let's do 5x plus 4 and my y sub 3. And they're parallel. Are you surprised they're parallel or not?
No.
How should we have known they're going to be parallel?
Same slope.
Yeah. So here's my point of tangency. If you hit trace -1, enter. You can see that point of tangency is at 1, -1. Any questions about the first part? All right, the second part. What is the smallest slope of this curve? What's the smallest slope? Well, the easiest way to probably figure that out would be to graph the derivative. So let's do that. Let's go to y equals. Let's clear out all our other equations here. Actually, let's leave the first one on there. Let's leave the 2x cubed. Well, I'll take that back. Let's just graph the derivative, sorry. So that would be, what's the derivative?
6x squared minus 1.
Right, 6x squared minus 1. And let's hit graph. So this graph is the derivative. Its y-coordinate represents the slope of this graph. So if we just found the lowest y-coordinate, then we would know the lowest slope on this graph. So let's just hit second trace. Minimum is number 3. Go a little bit to the left, push enter. A little bit to the right, push enter, back in the middle, enter. So on this 4.1095 e to the -7th, that means move your decimal 7 to the left. So basically the x-coordinate is what? 0. So basically, on this graph, when the x-coordinate is 0, we find the lowest or minimum slope of -1. Okay? So what is the smallest slope of the curve? It'd be -1, because this y-coordinate represents the slope of this graph. So -1 is the smallest slope. And what value of x does this slope occur? What would I say? 0. Just to kind of check our work, we could go back and type the original one in now, under y2. So I'm going to type in 2x cubed minus x. And let's make this a thicker line by going off to the left and hitting enter, and then graph. So what that's saying is that this thick line, right here, it reaches its lowest slope, and that slope right there is -1, which was the y-coordinate on this graph. Any questions about that? All right, let's go ahead and let you keep working. Does anybody have any questions on the homework they've run into so far? All right, go ahead and keep working.